In this problem, we're asked to find the percentage of aircraft, individual aircraft, that could have ages between 10 and 17 years, and then do the same problem using a sample size of 49. And we're given that the mean age of the aircraft is 12 years and the standard deviation 6.5416 years. So we need to find standard scores for an age of 10 because we were looking for ages between 10 and 17 years. So the standard score, or z-score, for 10 would be 10 minus 12, which is the mean, divided by the standard deviation 6.5416. And this comes out to negative 0.3057, but when we look those up in the table, we're going to round this to a negative 0.31 because the table only does 2 decimal places. The z-score for 17 minus 12 divided by our standard deviation of 6.5416 gives us 0.7643, and again we'll round that to 0.76 because the table is only 2 decimal places. And I have put out pieces of the table here. So we can see that the 0.76, we go down here and find the 0.7 and go across until we were under the 0.06. So if we added 0.7 and 0.06, that's 0.76. And we find our area given to us as a decimal as 0.7764. So that means that the area to the left of an airplane weight of 17, or an airplane year of 17, which was a z-score of 0.76, is 0.7764, or 77.64%. We do the same thing with the z-score for 10. It was negative 0.31, so we go down to negative 0.3, and we're in the 0.01 column, so we read off 0.3783. And the meaning for that is that the area to the left of an age of 10, or a z-score of negative 0.31, is 37.84%, or 0.3784. Now the problem asks us ages between 10 and 17, so we can see from the sketch here that we need to subtract the area for to the left of the 17 age and the area to the left of the 10 age. And when we subtract those, we get that there must be 0.3981 area between 10 and 17, or between negative 0.31 and 0.76 on your curve. That is a decimal. It asks for a percent, and it asks for a percent rounded to the nearest integer. And when we change 0.3981 to a percent, it's 39.81. When we round it to the nearest decimal, we get 40%, and you answered 39%, which is why it counted that wrong. Part 2, you're going to do the exact same thing, but we're dealing with a sample of size 49. And we learned in class that when we have a sample and we're doing z-scores, that we need to adjust the standard deviation by dividing by the square root of the sample size. The square root of 49 is 7, so our new standard deviation is 0.9345. And I used 4 decimal places because they used 4 decimal places when they gave their standard deviation. So go through the same process to find the z-score, only this time I'm using my adjusted standard deviation, and I get negative 2.14, and again I rounded to 2 decimal places because that's what's in the table, and I got 5.35. So when I go to the table, the negative 2.14, I go down here to negative 2.1 and over to the 4, and I read off 0.0162. And this says any z-score above 3.5, I can use 0.9999. I subtract those two values and I get 0.9837. The directions say round that to the nearest tenth, so that would be 98.4%.